Hi, that we continue section 10.g, the convexity. And now that we discuss the definition for Macaulay convexity. So remember that the Macaulay convexity that we have used the delta. So instead of differentiate with respect to I, that we differentiate the present value by delta, which is equal to log of 1 plus I. So delta and log of 1 plus delta and I are similar the quantity. So basically the I and log of 1 plus I is very similar when I is small. So this is slightly different definition. So the definition of Macaulay convexity that we write the M sub Mac. So this is defined by the second derivative. So d square d delta square of P of I over the P of I. So maybe we can write the P of delta, but anyway, so that we differentiate with respect to delta. Okay, so what's the formula for the Macaulay Macaulay convexity? So the Macaulay convexity is C. So that is obtained by the same way. So the P of I, so the present value is equal to the summation of V to the power T times the A sub T. So what is the first derivative? So first derivative of P is equal to, okay, so the V is equal to the 1 over 1 plus I, so that is the exponential of negative the log of 1 plus I T, A sub T. So this means the summation of e to the power the negative delta T times AT. So the first derivative, just the delta comes here. So the negative, the T times the e to the power, the negative delta T, A sub T. So the second derivative is once more. So that means the negative T is multiplied again. So the T squared times e to the power, the negative delta T, A sub T. But if you go back to the expression with the V, this becomes T squared times the V to the power T times A sub T. So the convexity Macaulay version is equal to the PI in the denominator, and the numerator is summation of T squared, the V to the power T, A sub T. So as a formula, this is simpler than modified convexity.